let's go ahead and look at a specific example. So what this example is talking about is we have a rocket and that is launched with an initial speed of 96 feet per second. That's defined as our function above. And we want to know the instantaneous velocity. But before that, I want to make sure that I go back over one more time what's going on here. So if this is my function, I want to know what's happening at time A and let's say B. So this point right here is my point A, f of A. And if I draw a tangent line there, you're going to see that that tangent line there is going to be increasing, and this velocity is increasing. Now, over where I have B, this would be my point B, f of B, and the instantaneous velocity here is going to be decreasing. The slope is going down, and you'll notice that this corresponds with the increasing portion of my function. When the function is increasing, the slope is positive, and when the function is decreasing, the slope is negative. So I'm going to start with the first question is, what is the position? Which in this case is the height after 1 second. So what that means is I want to find what S of 1 is. All right, I go ahead and plug that in. S of 1 is negative 16 times 1 squared plus 96 times 1. And my output of that is 80. So that first point that I'm looking at here is if I'm looking at 1, this point is 1 comma 80. The next thing I want to find is the instantaneous velocity. Now remember, this is a rate of change, and the rate of change for this is the change in y over the change of x, which is just the idea that this is in feet per second. So I want the slope of the tangent line, which is equal to the limit as x approaches 1, or in this case, we really should label that t because it is in terms of time, of s of t minus s of 1 all over t minus 1. And this will give me the instantaneous velocity when the time is equal to 1, or the slope of that tangent line in green that I have drawn. So writing that all out means that I have the limit as t approaches 1 of s of t, which is negative 16t squared plus 96t minus s of t, which we found before, which is just 80 all over t minus 1. We want to take the GCF out here. The GCF is a negative 16. Then we are left with the limit as t approaches 1 of negative 16 t squared minus 6t plus 5 all over t minus 1. I still can't use direct substitution. That will give me a 0 in the denominator. So now I do the limit of negative 16. I go ahead and factor what I have, and I'm left with t minus 5 times t minus 1 all over t minus 1. Now that reduces and is equal to 1. I can go ahead and use direct substitution. So I get the limit as t approaches 1 is negative 16 times t minus 5. Direct substitution gives us negative 16 times negative 4, or the fact that is equal to 64. Or in this case, that slope of that tangent line that we had drawn before is equal to 64 feet per second. So if I go back and take a look at what I'm talking about up here, so if I go way back up to the beginning, the slope of this line, the instantaneous piece, is 64 feet per second.